Hi folks! Thanks to be here for this talk about zero downtime to be here for this talk about zero downtime deployment on Kubernetes with Hazelcast. I am Nicolas Fränkel. I've been a developer for a long time, or an architect or a team lead, whatever have you, while technical roles, and since a couple of years I'm a developer advocate. I'm by far a Kubernetes expert, but we live in interesting times. There are a lot of things to learn, and Kubernetes is among them for me. I work for a company called Hazelcast. Hazelcast has two products. The first one is an in-memory data grid, and you can think about an in-memory data grid as distributed data structures. So you can shard your data, you can replicate your data across nodes in the cluster. The other one is Hazelcast Jet, and it's an in-memory stream processing platform. And I won't talk about it further because I will use them in my demo. So the first question is, why shall we do zero downtime? Well, the first reason is because business wants it. If you are an e-commerce shop, and I know this is a pretty popular example, or overused, well, you want to sell. You want to sell all the time. So downtime means first, you don't sell, and during this time, your customers might buy to another shop. They will probably wait not that much time. They will probably decide, hey, this shop is closed. I will go to another shop. So it has a direct impact on the business. And the second reason is a side effect, is because like the big companies out there, the Google, the Facebook, the Amazon, Apple, like the big ones, they are always up. Their applications are always up. So that users who don't know about IT, they start to expect that applications are always up. So if Google's applications are always up, why yours are not? I mean, they don't understand the difference. People who work in IT, we have been working in IT for a couple of years, and yeah, we know how to deploy with downtime. We go to the proxy, we set a static page, we're saying, hey, please come back. But the big ones, they deploy all the time. They don't do like that. And so people get used to that. And if you cannot compete with the big ones, then probably you will have a problem of image saying, hey, why are you doing that? And if we are talking about zero downtime, I'm sure you are pretty familiar with the BlueGreen deployment model. So the idea between the BlueGreen deployment model is you've got your production environment, and let's call it blue. And meanwhile, you have a similar environment, let's call it green. But for the moment, the users, they are directed to this blue environment. So at the moment, this environment runs the version 1 of the application. And at some point, business or in an automated fashion decide, hey, let's deploy something on the green environment, the V2. And when it's ready, the users, they can be directed to it. And the next step, of course, is let's deploy the V3 on the blue environment. And again, let's switch between the blue and green all the time. So the prerequisite is we must have those like two similar environments. There is an alternative to that. Here we have like one single database or like one database per each environment. And I will come back to it later because it's pretty significant. It has a huge impact. And it's a real problem when we do blue-green environment because everything is related, every issue is related to states. And it's not only about blue-green, it's about when you want to do zero downtime, you need to have like to handle state. And state is found in two places, like in the application themselves, on the application nodes, probably user sessions. Even if we don't want to use user sessions, in general, we use them because it's not feasible every time to go to the database or to the dev server or to any data store. So when the user logs in, for example, you're probably happy to store his first name and last name in the session and then display it in every screen. And of course, there is state in the database. And Kubernetes came and proposed something very interesting, the rolling update principle. So it's like different from BlueGreen. We have a single environment, we have different pods, and we will like upgrade each pod in turn, and you can configure how long it can take, you wait until it's ready, whatever, but this is the basic principle. And again, still, it doesn't solve the step-related issues. It doesn't solve the sessions problem, it doesn't solve the database problem. On the session problem, I believe it's a solved problem. Like, we have session replication. We have been doing session replication since ages, just because if we store states on a specific pod and the pod goes down for whatever reason, even if we don't want to deploy something, well, we need to keep the session data. So we have been doing session replication since ages. I won't go in detail over that. Just in the demo, it just works and you can check the documentation. But the real issue is on the database side. And we have actually two options that I mentioned. We can keep the same database, and that's the way I used before. And I became like aware of some problems. And so let's go over this option, and then we will see how we can have two different databases, and like that's a much better choice. So first option, keep the same database. It seems like it's the best idea. However, there is one requirement, is that the application needs to cope with two versions of the schema. Why is that? Well, here we have 3 pods, and we have one single database pod. And let's do a rolling upgrade with Kubernetes. So if we just do a rolling upgrade, first we start with the first pod, and then we go to the database. And of course, the old 1.0 pods, they cannot cope with the 2.0 version because there is no way they could have like inferred the future, and it breaks. So the idea is, it doesn't work like that. The idea is that the 2. Version pods needs to work with a 1.0 schema. And it's completely possible. So let's do that. While we do the 2. Version, when we develop the 2.0 version, we say, okay, if we have this schema version, we do this. Otherwise, we do that. It's okay. It's a bit more work, but it works. So we just like do the rolling upgrades on each pod in turn. When they are all ready, then we can migrate the database version. And everybody is happy, unless we need to roll back. Because yes, we are all very good engineers, but sometimes, for whatever reason, we need to roll back. And in that case, we cannot roll back, because as soon as we try to roll back, well, it's the same problem as before again. We have this 1.0 version that cannot handle the 2.0 schema. How can we do that? Well, let's have a very concrete example. Again, I've been working in e-commerce, so I'm using that e-commerce example a lot. We have this like stupid schema. Customer has multiple cart lines, and every cart line has one product. This, I started as an architect. I started with this schema. My application became very popular, and now the business comes, and the business has requirements as always. And now what they want is they want to keep a track when a cart was created. And then after some time has passed, there will be a job that checks every time and say, oh, it has like 24 hours. The person has kept their cart. So they actually like didn't order, but we still have the cart, and we can send them a reminder and tell them, hey, we have this discount for you. You forgot perhaps to check out your cart. Hey, here are 20% of discounts, please buy. I mean, this is a pretty normal for business. And so we need to redesign our application. And for that, we introduce now a new cart table with a dedicated last modified attribute that will keep the timestamp when the cart was last updated. Okay, how can we handle that like from the application point of view? Well, as I mentioned, it's a breaking change. So there is no way that your application can cope with this breaking change. So we need to handle the forward and the backward migration. So the forward migration and the backward rollback. So the idea is that we would need to split the breaking change into a series of changes that are compatible side by side, so we can always do a rollback if necessary. So how can we handle it for our e-commerce use case? The first step would be, hey, let's create the real cart table, and the app still uses the old data model. And now, every time we do a change on the cart line, when we add a cart line, for example, we will first check if like a cart line exists for this customer. If it doesn't, we will create this cart and we will attach it to the customer. And this way, if for whatever reason we need to roll back, well, that's not an issue. The database schema will have this cart table that the app doesn't use anyway. And when I say trigger, it can be like a real trigger because your database software can handle trigger. It can be through the code. It can be through anything. I'm not prescriptive in that. The idea is just, hey, like when a cart line is inserted, we check if the first cart line for this customer, if it is, then we create a new cart in the cart table. Okay, the second step is now the cart table becomes a source of truth. So the application uses the cart table, and again, there is a trigger that updates the cart line with the customer ID every time it inserts it. Now, if we need to roll back, the cart line table will still be used, but it has the customer ID, so it's fine. The third step is we will migrate the in-touch data, and that's where the problem lies. And the fourth will be we will be doing cleanup. So we will remove the additional customer ID column in the cart line table. So why is the migration of untouched data a problem? Well, if you've got a couple of lines, that's fine. Because when we are doing this like migration, we infer that people are still using our shop. But perhaps there are people who had like cards who were not touched, and those needs to be migrated to the new schema as well. And the real issue is it can be a lot of data. It can be a really, really big lot of data. So it's going to take some time. And during this time, that means that we need somehow to have like the application still working meanwhile. So it's this third step is where the real issue lies. And it's not only that. Of course, it will require you to like decompose this change into steps. Might not be that easy every time, so that you can roll back. And after that, so you have this breaking change. You will like split it into non-breaking changes compatible side by side. But you can still only roll back one single baby step. You cannot roll back the whole breaking change. So you can just only roll back one step. It will need to be planned across the whole organization. It impacts developers, it impacts like database administrator, it impacts the ops, and probably it will impact the manager who will need to plan. So it's a lot of organizational like effort. And as I mentioned, you will need to migrate data anyway. If it's a couple of lines, that's fine. If it's a lot of lines, yeah, not so fine. It might take too much time. And this decomposition of step is fine. It can be planned if you have like a small organization that only does it once. But imagine that you need to do those changes and they need to be deployed in parallel. It might not be possible at all. So the second option is, hey, we will need to migrate data anyway, so at least we need to embrace it. So instead of having a single shared database, we have the blue database and the green database. So how do we handle the migration? And that the real game changer here is we won't use jobs. We won't like start a bad job and end it. We will do streaming, meaning that we will get the changes as soon as they come, and as soon as they come, we will replicate those changes into the new schema. And you might have heard change data capture before, and that's how we capture the change from the database side. The problem of the database side, it's not an even source. So change data capture, we will change that SQL database to an even source that we can stream. And the benefit is that the developers, they are not impacted at all. It's completely parallel to how they work. And it's not actually like related to BlueGreen deployment. It can work with any deployment option you can choose, like for canary release. So change data capture, as I mentioned, is the way that we can like make a normal SQL database into an even source. So every change is tracked, every insert, every delete, and every update. So here we have like our starting architecture. And the starting architecture is actually, we have 3 pods of the same deployment. So pod v1, pod v1, pod v1, and they are using the blue database. The next step is we will set up the green database. So it's just the setup, nothing happens. It's just, hey, let's create the schema and the constraints and whatever. Now the third step is we will create a data streaming job that will read through data capture from the blue database, and it will forward the changes to the green database. So every time there is a change in the blue database, it's replicated in the green database. And because of like the data streaming world, we can do some transformation because just replicating would be very, very easy. But here we are doing transform, so we adapt the changes from the old schema to the new schema. Of course, now we can start to do the rolling update, and at some point, one of our V1 pod will become a V2 pod that is configured to use the green database, and it has all the data it needs. After some time, all the nodes will have migrated to this green database so that the forward job doesn't need to do anything because, well, there are no more changes. And the difference with the previous approach with one single database and you need to migrate untouched data is that the forward job, it migrates data that has been changed in the past. So it's able to read stuff that happened before it was started. And so that is actually the definition of untouched data, but the rights are still there. Here I was too lazy to do it, but you can think about you need to design a backward job that do the exact opposite in case you need to roll back. And if you don't need to, then of course afterwards you are happy to do some cleanup, you remove the job and you might keep the blue database for a bit more just to be sure, and then afterwards you do the cleanup. So everything is fine. And how can we implement it? Again, as I mentioned, for session replication is a solved problem. You can use Hazelcast for that. In-memory data grid, it's perfect. It's a perfect use case. In the demo, I will be using Spring Sessions because Hazelcast is a Spring Session implementation. For the database migration, I will be using Hazelcast Jets for change data capture with the help of Decomposition. And as I mentioned, Hazelcast MDG allows you to store your data in memory so that session replication becomes a non-issue. On the other side, we have Hazelcast Jet, and Hazelcast Jet is a stream processing engine. It can read from different sources and write to different targets. And meanwhile, it's distributed and you can do transformation, enrichment, whatever you want. So here, in that case, this is my design. I have this Jet cluster and I have the blue databases. I will create my job and it will use the Hazelcast Jet jar, which uses intern debizium.jar, which will in turn use debizium MySQL.jar because debizium is actually an abstraction layer that you can use to read from different databases. Postgres, here I'm using SQL, but so that in the end I could use nearly the same code to do it with Postgres. So I could even have a MySQL blue database and a Postgres green database. That's not an issue. I believe I've talked a lot, and now it's time for some demo. So here I have everything in IntelliJ, and at the end of the talk, I will give you a slide with all references that you can check. And this is in a GitHub repository, so you can use it out of the box. I've created an application, and this application is a Spring Boot application, but I don't want to go into too much detail. It's just a Spring Boot application with a POM. And how does it work? Well, it works like the following. I have deployed already everything like the blue version on Kubernetes. So I'm using kind. I have been bitten in the past by Minikube, so I hope this demo works today. The first thing is I will need to log in. So I don't want to implement Spring Security. I just want to keep it simple. So how do you log in into this application? And very important, you cannot do anything. You cannot check your cart. You cannot browse the catalog unless you have logged in. So how do I log in? I log in by like choosing a user here. So here I have user Joe, and now I am like authentified, logged in as Joe, and I can browse the catalog and I can put stuff in my cart. So here you can see in the right hand corner, I have like displayed the node name and the version of the application, just to like show you how you can, like how it works. So let's say that now I log in as Jack, and Jack has nothing in his cart. So I will add like one t-shirt, and perhaps I will add like William. I will add like 2 hoodies for William, and I will add Avril. I will add 3 stickers. This is just to show you how we will migrate the data. So I need some data to start with. Let's get back to Joe and add like a couple of marks. Here, this is our initial state. So if we go and check on Kubernetes, I have aliased the kubectl to k because it's much more comfortable, and I can check the pods here. And normally I should have 4 pods. It takes a bit of time. I have the blue database, so I have a deployment of 1 pod, 1 replica for the database, and I have a deployment of 3 pods for the application. The first step is actually to deploy, as I mentioned, the green database, the green environment. So I will apply infrastructure kube green. So this is just the database, the new environment. So get pods W. Normally it should be already up. It's very, very quick. So yes, it's already running, and we can check the logs. So k logs green -f. So MySQL is starting, and we should wait a bit until it tells me that everything is fine. Shutting down MySQL D is good. It's ready. It starts very, very quickly. So now we have a new MySQL instance. We are very happy. The next step is to actually deploy the forward job. So let's deploy the forward job. K apply F infrastructure kube forward. K get pods W. So it's already started, and K logs forwards F. That's very interesting, actually. You can see that it already has started to replicate data to the green database, like from data that was there before it started. So now on the green database, you already have the exact same state as on the blue one, even though we just started the forward job. And if I just like go back to the shop and I add 1 more mark, we can see that instantly the forward job caught this change and updated the quantity on the green environment. So now every time we do a change, it's captured, transformed, and forwarded to the green environment. So the next step is obviously to do the rolling upgrades, which is the least problematic stuff. So K apply F infrastructure kube and application 2.yaml. And here, k get pods w, we can start to, well, we can continue shopping. And the idea is that at some point, magically, I will be on a v2.0 pod. So here it's a REST call, so I will need to refresh. It won't be visible into the right upper right corner. Might take a bit of time. So sometimes my code, well, not sometimes, my front-end skills are pretty bad. So it might like squeal a bit and I will need to refresh the page, but it's only because I don't know how to write really correct JavaScript. So it's still doing its job. And it's taking some time, of course. No, I thought it was. So meanwhile, I'm keeping an eye on the terminal, and normally at some point, this like pod should get killed and replaced by a new pod. Let's see if it has been killed. So, hey, I am already on the 2.0 version. And it was like, you saw nothing. And of course, I can continue now adding new stuff. So how does it work? Well, there is nothing magical, actually. The application is not that interesting. The forward job is a bit more interesting. We can see the source, and we can see that it's a plain normal Java application. Like, it has no dependency on Spring at all. It's completely like agnostic to the tech stack of the application. It's independent. It's just like a plain main like application. So here you start it with main. And here we can see a view of the pipeline. And I won't delve into the detail of what the pipeline is. Basically, the pipeline is the code that you send to the Jet cluster to get executed as a job. And here we can see that it reads from the blue environment and it maps the record, because here we are using records, and we don't need to have this class itself. We just transform it to a map, and we map it further afterwards to call parameters, because when we write to the green environment, what happened is what we are doing is actually we are calling this like function called insert cart line. And what this function does is just a call to a start procedure. So whatever like technology you are using, you can do like JDBC, you can do GPA, you can do Hibernate, you can do whatever you want. In all cases, it will work. Like, it's just like plain simple Java code. Yeah, you can see it here, insert cart line, and it's a callable statement. Well, I believe I'm at the end of the time that is allotted. So takeaways for you. I believe that zero downtime is within everybody's reach, which was not the case before. I believe before I told people, hey, perhaps it looks like really hard. But with this approach, anybody can do it. On one side, for like data that is on the application pods, session replication, solve problem, just configuration and works. And on the database side, you have change data capture and data streaming. And it works like a dream. Thanks for your attention. You can read my blog, you can follow me on Twitter. As I mentioned, you can check the Git repository. Everything is on Git, so you can do that at home. And if I got you interested in Hazelcast, you are welcome to join our Slack. Thanks again, and have a good day.